Alright, so this is where I'm going to show you how to use your CAS to answer that application question that I was doing as an example for 6J, and some of the functions that will help you a little bit on your CAS as well. So you might want to pause here and make sure you've got the questions written down. I'm just repeating the answer to the questions that we did just before, but showing you with the CAS. So with question A, it says to find the length of each edge. You can't really do that with your CAS. We're going to have to look at the diagram and work those out. We worked out that the length and width were the same, which is 22 minus 2x, and the height of the box is going to be x as well. Now B we can use to help us out. It says find the volume of the box in terms of x. So we need to come up with some rule. We worked out that volume is length times width times height. So we could just times all those things together, which I'll do right here. I'll show you here. So it's going to be 22 minus 2x, and then another 22 minus 2x, and then an x as well. Okay, so you could have left your answer like that, except I expanded it as well. So I said you could use your CAS to help you out. If you want to expand something out really quickly, just use the expand function. So that's menu, algebra, and expand. Now you need to make sure what you're expanding is inside these brackets here. So that's how I got the rule nice and quick. Alright, so we've answered B. Now you could have had, this is your answer, you could have had that, it doesn't matter, it's the same thing. C, we're trying to find the volume of the box. Now what you could do is grab this rule here. If you press enter, it's going to copy it down. We want to find the volume when x is 1. You could do this. Make x equal 1 here, make x equal 1 here, and make x equal 1 here, and it's going to give you the answer. Except that's a little bit time consuming, and it might take a while if you need to do it for multiple lengths of x. So I've shown you this function before, but we're actually going to define the rule that we found before. So we're going to define the rule for volume. So I'm going to go to menu, actions, and then define. Now I don't want to type the whole rule out again, so I'm going to go up. You should be able to do that on your CAS. Press enter. See how it's copied it down there? You don't even need to write it again. But we need to give this rule a name. So normally you're going to have f of x equals, except we've got a rule for volume here, so I'm actually going to make it v, just so it's a little bit more clear. And it's defined. Now, if you want to find the volume for any length of x, you just put your length of x in here. So we wanted the volume when x is 1 centimeter. There's our answer. I think you can see. I'll get that out of the way. There you go. So let's do it for the next one, which is CII. So we wanted the volume when x is 10. There we go. See how quick and easy that is? I want the volume when x is 7. All I'm doing is changing that number. That makes it really fast and really easy. So let's move on and have a look at the next question. So it says find the values of x where the volume's 500 centimeters cubed. We can use this v of x thing here, except I'm going to show you using the whole rule instead. So I'm going to copy the rule down here. Now we wanted to know the length of x when the volume is 500. Now the solve function that we should be using here, because this would take a little bit of time doing it by hand. So we want to use the solve function to make it quick. So you go menu, algebra, solve. Make sure you got the brackets around your rule. You need to tell it what you're solving for as well. So you put a comma at the end, and we want to solve for x, so we're going to put x in there. Then I'll press enter, and this has showed up. Now this is an exact answer. It looks really, really confusing, doesn't it? Let's find out what the approximate is instead. So to find out what the approximate answer or decimal answer is, you see that those little squiggly equal signs, or look similar to an equal sign? That's what we need. So I'm going to go Control, Enter, and it's given me the decimal answers. So we can see we've got our 1.3, 1.34, 6.67, and 13.99, which we found before. So let's move on to the next part, E. we need to find the maximum volume of the box and state the length of x when this occurs. So I like to use a graph to do this because then you can see where the maximum is. So I'm going to open up a graph. Actually, before I do that, I'm going to go up and copy our rule. Now on your computer you can do Control C. You can do the same thing on your CAS. So press Control and then C. And it should be copied. I'm going to start a graph and then Control V is paste. There we go. You didn't even have to write it again. And press Enter. Now our graph's going to look like this, except this is a bit confusing, isn't it? Because you can just see you've got a vertical line on the y-axis, or that's what it looks like. It's because of what our window looks like. We can't actually see the whole graph. This is just a little snapshot of it. So I want to zoom out so I can see what's actually happening. A good idea is to change your window, but you can do a function down the bottom here which is zoom fit. It zooms out a little bit so you can see the picture a little bit more clearly. Now you can grab and drag on your CAS as well, so you can move it wherever you like that. Alright, now let's evaluate what's actually going on here. Remember how we spoke about before, you can't have negative lengths and you can't have negative volumes? This y-axis here, that's our volume. You can't have negative volume, so we're not going to have this negative section. This x-axis here is the length of x. You can't have negative length, so we're not going to have that bit there either. So this section of the line, that's not going to exist. We don't need that. Okay, and this section over here, remember how it can't be longer, the length of x can't be longer than 11 centimeters, otherwise the box doesn't exist. So this section here, that doesn't exist either. We're only looking at this middle bit. Okay, now we didn't really need any of that to find out what the maximum is. The maximum is here, isn't it? So we're going to use a calculator function again to make it quick. We're going to go Menu, Analyze Graph, and we want to find the maximum. So we'll click Maximum. You need to choose a side on the left of it. You need to choose a side on the right, or spot on the right, sorry. And there we go, there's our answer. So this is saying that when x has a length of 3.67 centimeters, hopefully I got my numbers right, you've got a volume of 789 centimeters cubed. So that's our maximum volume. So if we're going to write our answer, we could say that the max volume is 789 centimeters cubed when the length of x is 3.67 centimeters. Now the next one, F, we're drawing the graph. Now we've almost done that already here. We just need to make it so it looks, it's a little bit easier to understand. We can see all this stuff that doesn't really matter to us. See how we've got all this clear space down here and clear space up here, but also sections that we don't need, like that bit there and that bit there. Let's get rid of that. So let's change our window. Now before I change my window, I want to have a look at this and just evaluate the parts that I actually need. So I'm going to need from 0 when x is 0 to x is 11 over here. But I only need from when y, or v, is 0 up to, it looks like, well, the maximum is 789. I'm going to make my maximum 1000 though, just so I can see a little bit extra. So to change your window, similar to what we did before, we go Menu, Window Zoom, except I want to really customize it this time. So I'm going to go to Windows Settings. I get to choose everything here. Alright, so the lowest value for x I want is 0. The highest value for x I want was 11. We can set our own scale. I'm going to say it's 1 to make it easy for us. The lowest volume we can have is 0. And our maximum volume was just under 800, I think. What was it? 789. But I'm going to make it 1000 here, just so we can see it. And again, you can put the scale as anything you like. I'm going to make it a scale of 100. There we go. See how this is a much nicer picture for us? So if we're sketching the graph, this is all we really need to copy, isn't it? Something that you do need to show though, is any endpoints or x-intercepts. We've got our maximum here, we worked that out before, but you need to show this point down here, which would be 0, 0. You need to show this point over here, which is also another x-intercept, which is 11 and 0. The 11 is actually above the 10 right here. It makes it look a little bit confusing, but the 11 point is actually over here in the corner. Okay, and G was state the domain. So the appropriate domain is what we have down here. Domains are your x values. So we've got from 0 to 11. They're the only ones that are going to work for us, and I explained how that one worked just before. So hopefully that helped you out a little bit in terms of using your CAS quickly rather than doing everything by hand and using a lot of time. Using these techniques is going to help you a lot in analysis tasks. Okay, thank you guys.